Hello, this is Matt from Heaney Apps, and this is part 2 in our 7-part Saturday full game tutorial series where we will make the full iPhone game 7 Sides in Xcode using Sprite and Swift. So far we have the base structure of our colour wheel, the 7-sided shape. In this video we will deal with tapping the screen to spin the colour wheel, we will code for each of our sides to have a different colour, and we have to set up a custom class for our sides. So by the end of this video, your game will look like this. So let's jump back into Xcode. So back into Xcode and back into our game scene. Now in this video, we will start by making our colour wheel spin when we tap the screen. And this will be a very quick thing to do, because as you may remember from part 1, our 7 sides that make up our colour wheel are all children of our colour wheel base, which was the big red square. So they're all attached to the colour wheel base. So all we have to do when we tap on the screen is rotate our colour wheel base and it will look like our colour wheel is spinning. So as we want this to happen when we touch the screen, outside of any other functions, we will set up our touches began function. And this here will run when we tap on the screen. So anything between these two curly brackets is going to run when we tap on the screen. So all we have to do is set up and use an action to make our colour wheel spin. So a different side will move to the bottom of the colour wheel. We want this to happen over 0.2 seconds, so it's quick, but we can still clearly see the colour wheel spin. So in the touches began, we will set up a brand new action, which we can run on an object to make an object do something. We will say let, and we will call this action spin colour wheel. This will be an SK action, and this action is going to rotate whatever we run this on by a certain amount over a certain duration. The amount we want to rotate by is 360 degrees divided by 7, because that is one full circle divided by 7, because we have 7 sides. So we could do this in radians, but we will use our convert degrees to radians helper function, and we just pass in 360 degrees divided by 7. We want this to happen over 0.2 seconds. So now any object we run this on will spin by this amount, about 51 degrees, over 0.2 seconds. Now the thing is, I think this is a bit weird, but as this is a positive number, this will make an object spin anti-clockwise. If we want it to spin clockwise, it has to be a negative number, so we will do negative whatever this number here is. Even though this would work with our colour wheel spinning clockwise or anti-clockwise, I just think it looks better spinning clockwise. So now it will spin any object that we run this action on by about minus 51 degrees. So it will spin it about 51 degrees clockwise. So all we have to do is take this action and run it on colour wheel base, like so. And because all of our sides are attached to this, this is that big red square, that square will rotate and it will look like our colour wheel is spinning. Okay, and just with that, that would make our colour wheel spin when we tap on the screen. Now before we run it, there's one more thing I want to do, and that is to do with this line just here. Because basically, at the moment, we are redeclaring this exact same action every single time we tap the screen. So rather than doing that, we will copy this, we will delete it, and we will declare this globally within the scene. This way, this action is set up just once, and we can simply run it when we tap on the screen, rather than redeclaring it every single time. Okay, so now when we tap on the screen, our colour wheel base is going to run this action, so it will rotate clockwise by about 51 degrees over 0.2 seconds, and because all of our sides are attached to this colour wheel base, it will now look like our colour wheel is spinning. So to see exactly what's happening, before we hit run, we will give our colour wheel base a colour again, we'll make it red, and now we will hit run. So when we tap on the screen, we will rotate this big red square, the colour wheel base, like so, and we are rotating it enough for a new side to slide in and be at the bottom. So all we're doing is rotating that big red square, and because all of our sides are attached to this big red square, because we added them as children, it looks like our colour wheel is spinning. So now that we know exactly what's happening, let's once again remove the colour of our colour wheel base, like so, run again, and now that we can't see the big red square, if we tap, it looks like our colour wheel is spinning. Okay, so that's pretty cool, and I actually think this looks surprisingly good all in blue. However, in 7 sides, we want each side to be a different colour, so it won't stay this way for long. Now we will get to the stage where we can make each side be a different colour later in this video. However, before we can do that, there's something essential in our code that we have to do. So let's jump back into Xcode and let's take a look at what we have to do. So let's move into our prep color wheel, where I'm sure you remember from part 1 in this series, we are adding a brand new SK Sprite node for our side. This side will be the blue side, and we're adding this to our color wheel base. We are rotating our color wheel base, and we're doing this 7 times, so we get 7 sides, which make up the color wheel. Now, before we can move on, there is something very important that we have to do in our code for our sides. This will involve setting up and using a new class. I'll explain all in just a few moments, but at the start of this series I recommended that if you hadn't worked with classes before, to go check out the videos about classes in the Swift Free series on this channel. That is where this will now come into play. This next part of the video will deal with setting up a new class which will inherit. This will be dealing with properties, initializers, and super initializers. Now the concept of classes is far too big to explain in full here in this video because we have to focus on what we need to make this game. So if you haven't dealt with classes with inheritance before, check out the videos in the Swift Free series about classes. There's 2 different videos. It's probably worth also looking at enums and structs. In that series they all sort of link together, and we will be using all of these skills in this series. So if you haven't seen those videos and you haven't used enums, structs and classes before, I'll put links down in the video descriptions to go check out those videos. Go check those videos out and come back. And the rest of this video will move on as if you have seen those videos, or that you just have an understanding of enums, structs and classes. So at the moment, all of our sides are SK Sprite nodes. They're standard image objects. And if we was to use SK Sprite nodes for these images, we would run into a major problem. To fix this, we have to set up a custom class for our sides. To fully understand the problem and to see exactly what we're going to do, let's take a look at some logic. So in 7 sides, our gameplay is made up with 2 main objects. We have the sides that make up the color wheel, and we have the balls that spawn in the center of the screen and will move to one of these sides. Now at the moment, our sides are sprite nodes. They are image objects in our scene. And you might be thinking that the balls are also images, so they will also be SK Sprite nodes. And as sprite nodes, all of the sides and all of the balls have a whole bunch of properties, a whole bunch of values that make the images the way that they are. They have a position, a size, a Z position, and many more. And as a quick property recap, a property is a value that any instance or any object that is of this type would have. And to access a property, all we do is take this object and say dot whatever property we want to get. So for example, our sides at the moment are SK Sprite nodes, and we can access the position property by saying side.position. We take the side, we say dot, and what property we want to get access to or affect. And just for an image, that's fine, that's plenty. However, if we was to use SK Sprite nodes, we will run into a major problem later in this series. We do need all of these properties for all of our sides and all of the balls. We need them to be image objects, so sprite nodes, but we need an extra property, one that a sprite node doesn't give to us. The problem is that once we've set the image of each side and of each ball, our code doesn't really know what kind of side or what kind of ball each object is. Our code has no idea that this image here is for a red side and this image here is for a red ball. To our code, that's just an image. And later in this series, when we move a ball to hit a side, because our code doesn't know what kind of side and what kind of ball these are, we effectively have no way in our code of knowing if the colour of the side and the ball match. I mean, we could try and use the image names, but even they don't match. These 2 images here are called side_red and ball_red. They don't even match. So we need a way of storing what kind of side or what kind of ball this is. So the sides and the balls need a new property for what type of side or ball it is. Then, when a ball and a side hit, we can just simply compare the type of the side and the type of the ball. With this, we will very easily be able to know if the ball and the side match. If they do, you get a point. If they don't, it's game over. So for this, we will make some brand new types, some new classes, which will make a new kind of object that we can use in our game. One new class called side, and one new class called ball. So just like we could then use an SK Sprite node, or an SK Label node, or an SK Shape node, or so many more, we would then be able to use two new types. An object could be of type a side, or a ball. Now these will actually be two different classes because there will be some differences. We can then make all of our sides be of type side, and later in this series we can make all of the balls of type ball. Both of these new classes will inherit from SK Sprite node, so both of these new kinds of objects will have everything an SK Sprite node has, and we can use it in the exact same way we can use any other Sprite node, but it will be like a custom version of an SK Sprite node. So all of the sides and all of the balls can have everything a Sprite node has, but can have this extra type property, which is storing what kind of side or what kind of ball it is. Once we have set these new classes up, we can use them in a very similar way that we would use a Sprite node. So take our sides for example. At the moment, when we declare all of our sides in our loop, we say let side equals SK Sprite node to make this a Sprite node. We then pass in which image we want this Sprite node to be. With our new class, we will simply say let side equals, and we then say this is of type our new custom class side, and we'll pass in anything that we need to set this side up. This way, all of the sides and all of the balls have this essential new property called type. Then, later in our game, when the ball hits the side, we will be able to very easily compare the side and the ball. If it's the red side, the side will have a type of red, and if it's the red ball, the ball would also have a type of red. When they hit, we can just take the side's type and the ball's type and compare them. Simple. If they match, then they're the same type. If they don't match, then they're not the same type. So that is what we have to do, and why we have to do it. So we need two new classes, one for the side, one for the ball. Now we won't be setting up the ball class until part 3, so don't even worry about the ball class just yet, but it was really important for understanding why we're doing this that we looked at both classes now. So forget about the ball class for now, let's focus fully on the side class. So let's jump back into Xcode and let's code this. Okay, so that is what we have to do. We have to make a brand new custom type, which will have everything a Sprite node has. So it'll still be an image object, but it will have an extra property to store what kind of side this is. It's worth pointing out that Sprite nodes do actually have a color property. So for example, here we could say side.color. And you might think we could use this property to store what kind of side this is, and get the exact same outcome. Now the color property can be used to add a bit of a tint of a color to your images, so you don't really want to be affecting that unless there's a reason you want your images to have a slightly different color. So we don't want to be touching that, we don't want to affect our images. So that's why we're not using the color property. Also, we don't really want to use this color property for this anyway, because it would really limit us in this game. Imagine you released a game like this onto the App Store, and everyone just went crazy over it. And you wanted to release another version of it with another theme. You would be completely limited to using colors. So say you wanted to use numbers, or words, or cars, or emojis, or flags, or whatever, you wouldn't be able to do it. So this way, we have so much more freedom with our code. So that is why we're not using the color property, in case you were wondering. So we have to make a brand new custom class for our side. So what we're going to do is set up a brand new file just for this new class. So here in Xcode, we will go File, New, File. It'll be an iOS Swift file, and this will be our side object. and we will have a brand new file called side object that will look like this. So for classes, you normally do a file for each class. As we will be dealing with stuff from SpriteKit, we have to import SpriteKit, and we can now create our brand new kind of object, the side class. We will say class, we will call this side, use a capital S for side here, because in our game scene we have declared all of our sides as side with a lowercase s. So this has to be different to what you called your sides in the game scene. And even though this will be a brand new type, so a new kind of object, we want all the stuff you get from being an SK Sprite node, so we will inherit from SK Sprite node. So now here in this class, we can set up the new properties that anything that is of type side will have. So anything we declare here will be a new property. Then anything that is of type side, it will have all of the properties that any sprite node would have, so position, size, so on. But it would also have a property for whatever we declare here. We will be able to use and access its dot position, its dot size, its dot z position, all of those, but also dot whatever we declare here. So what do we want this new property to be? Well, we need a brand new constant called type. This will store what type of side this is. So we could do this as a string, where type would then equal something like red, or blue, or green, or whatever. We won't actually be setting a value to our new property here. We will take care of that through our initializer, so we can set the type property for a side when we make a new side object. So this equals whatever value here is just an example of what it could be set to. However, this leaves us open to a whole bunch of potential problems, because each side will have a type property, and each ball will also have a type property, and they have to match for the answer to be right. However, as a string, we are open to make typos, and if this happens, even though we mean for both the side and the ball to be green, these do not match. And if a green ball hit a green side, our game would not register this as a correct answer. And that's a huge problem. Same thing, we could set this up to be dark green. And again, these do not match. So rather than this being a string, we will set up another custom type for type to be. This will be an enum. This enum will make sure type will be one of 7 available options in the exact right way. So just like a boolean has to be true or false, anything that will be of our brand new enum type will have to be one of the set options. We'll be effectively doing the same thing as this, but completely eliminating any potential problems. So for now, let's get rid of this line because we're not quite ready to set it up, because we have to make a brand new custom type for type to be. So just like how each big class will have its own file, we will set up a file for all of our custom types, all of our enums and all of our structs. That will be accessible from anywhere in our project. We will also use this file to store any variables or constants that we have to access from everywhere in our project, as you will see in just a little while. So, brand new file, so Xcode, file, new file, again an iOS Swift file, and as this file will store all of our custom types that are enums and structs and any data that we have to use everywhere, this file will be our models and data. Hit create. So, brand new file. And in here, we will set up any new types which are structs or enums, and we will store any variables or constants that we have to use throughout our entire project. So in here, we will set up our brand new enum. This will be called color type, and here we can simply list all the possible types either the side or the ball can be. So effectively all of the different colors. Then anything that is of type color type will have to be one of these options in the exact right way. So we have an option for red, orange, pink, blue, doesn't really matter about the order of these, yellow, purple, and green. I think that's all of them. We should have 7. 1, 2, 3, 4, 5, 6, 7. Yes, so we should have 7 of these. And for now, as you will see very soon, it's actually really important that each of your options, so each of red, orange, pink, and so on, all start with a capital letter. You'll see why very soon. Now, anything that is of type color type has to be one of these options. This will completely eliminate any chance of typos or setting a side up to be a type that isn't actually a type. Now that we have this, it's accessible to our entire project. So Command B to build. We have to build this so we can actually use it. And back into our side object.swift. Now what we can do, we can set type up, but rather than being a string, this will be of type color type. So now the value that this property holds has to be one of these options spelt in the exact right way. So now there's only, for example, one way that this can be a green type. We can't make a typo because it would tell us that's not a real thing. And we can't enter an option that isn't really an option. So now we have to enter green, for example, in the only way that we can enter green. This completely eliminates any potential problems. However, we don't actually want to set a value here. If we was to set a value here, any object that is of type side would have the exact same value for this property. So if we set this property here to have a value of color type.green, for example, every side on our color wheel will have this property, but they would all be set to green, which obviously isn't what we want. We want this property to match whichever side we are currently making. So rather than setting a value here, what we will do, we will set up our initializer method, the function that we have to run whenever we want to make a new object that is of type side. With this initializer, we can take care of setting the correct value to this property for the side that we're currently making. So this way, rather than having one set value, when we make a new side in our color wheel, we can then effectively say this side's type will be blue, this side's type will be green, this side's type will be pink, and so on. So when we set a side up, then we're going to say what type this side is. So we need our initializer. And again, I know I said it, if you don't know what initializers are, or super initializers, or properties are, and you have no idea what I'm banging on about, go check out the Swift free series about classes and enums. So our initializer, what do we have to pass in when we make an object that will be of type side? So just like when we make a sprite node, we pass in which image we want. So this here is effectively an initializer for SK sprite node. We're saying what image we want to use. When we set this up to be a side, we have to pass in what type of side this will be as a color type. We'll then take this and set this to the type of the side that we're setting up. So take the type of the side and set this to the type that we're passing in. So that will let us set up an object that will have a type of side. Just like we could set up an object which is of type sprite node or label node or shape node or whatever. And because this inherits from SK sprite node, any object that is of type side will have everything a sprite node has. It can do everything a sprite node can do, but it will have the extra property called type. Through our initializer, the code that's going to run whenever we set up an object which is of type side, our code will literally say to us, what type do you want this side to be? In the exact same way as when we try to set up an SK sprite node, it will ask us which image we want this to be. With the value for type being passed in whenever we make an object which is of type side, we can set values for all of the properties that this side needs to be a side. However, as we inherit from SK sprite node, we now have to run our super initializer, which will take care of setting the properties that we have to have for this to be a sprite node. Because as this object inherits from SK sprite node, it still effectively is a sprite node, so we have to take care of setting the values that it needs to be a sprite node. So we have to run our super initializer to take care of this being a sprite node. And the one that we need is this. So when we set up a side, not only do we have to initialize everything the side needs to be a side, we have to initialize what a sprite node needs to be a sprite node. And this will ask us for a texture, so an image. It will ask us for a particular tint on this image and how big we want this image to be. And what we also have to do is include this. Click on the error, make sure not to add a breakpoint, double click, and we need this. We will not be using this in any way, and this won't actually affect us in any way. But if we make a new class which inherits from SK sprite node, we have to include this. Make sure not to add a breakpoint, one of these blue arrows, that will crash your game. If you did, right click, delete. So now the last part we need to set an object that is a side up is to say which texture this side is going to be. So now when we create a new object in our game that is of type side, not only do we have to say what type this is going to be, we also have to say what texture, so what image this is going to be. So you might be thinking, we've passed in the type, let's also pass in an image or a texture into our initializer. And we could do that. So whenever we make a new object that is of type side, we simply say this side will be this type and this side will be this image. However, we're not. We're going to do it in a better way. Because at the stage where we have to say which image this side is going to be, we know what type this side is going to be. Is it the blue side or the red side or the green side or the whatever side? And rather than passing in an image, we can use that type to figure out which image this has to be. So effectively, whenever we create a new object that is a side in our game, we will only say what type of side this will be. Then when it comes to setting the image that we want to use for this object, so this side, here in the initializer, we are going to say, if this side is the red type, use the red image. If it's the blue type, use the blue image. If it's the green type, use the green image, and so on. Now we could do this with a whole bunch of if statements. We could do this with 7 if statements. It says, if it's the red type, use the red image. If it's the blue type, use the blue image. But that sounds like a lot of coding. We could do it with a switch statement, effectively a big if statement. But again, we can do it in a better way. So, what is this better way? Well, this type property, not only is it going to tell our code what type of side this is, it's going to play a very big role in setting which image this side is going to be. How so? Well, we know type is a color type. So type has to be red, orange, pink, blue, yellow, purple or green, spelt in this exact way with a capital letter. Now, when I named these images, you might notice each image is called side underscore and then one of these options. So ignore the side underscore, we simply have our 7 options. So each side image is side underscore and then whatever the property type is. So the texture that we want to use is called side underscore and then whatever type is. If it's red, side underscore red. If it's green, side underscore green. If it's orange, side underscore orange. So to figure out the texture or the image this side needs, we haven't got to pass one in. In fact, we can figure it out right here by simply saying let side texture, this will be an SK texture, so the image this will be image named, and the image we want to use is simply side underscore and then the property type of the side that we're setting up. So if it's the red side, side underscore red. If it's the green side, side underscore green, and so on. All we then have to do for the texture is pass in side texture. So the image for this side will be the image from here. The color, which will be like a tint of another certain color on this image, will be clear because Will did a great job on making these images look really good. We don't want to mess that up by adding a tint. If, for future reference, you were interested in adding a bit of a color tint to your images, in addition to putting a color here, you also have to play around with a few other properties like the color blend factor to make it work exactly as you want it to. And the size will just be however big the image is. So side texture dot size. So now what we've done is we have fully set up a brand new kind of object, a brand new custom class called side. This will inherit from SK Sprite node, so it's effectively still a sprite node. It's still an image object, just a custom version of an image object. So anything that is of type side will have everything any other sprite node has, and it will work in the exact same way that any other sprite node will work, but it will have an extra property called type. Type will store what kind of side this is. Is it the red side, or the blue side, or the green side, or the pink side, or the whatever side? As it was essential that it was one of our available options, type is of type color type, our custom enum. So it now has to be one of these options. when we had this side's type, we could figure out which image this side had to be because the images were called side underscore and then whatever type that side is. So for example, if this side is the red side, the image would be side underscore red. If it's the pink side, side underscore pink, and so on. So when we set up a side, we passed in the type that we want this side to be to take care of setting what this side needs to be a side. And because it's a sprite node, we also had to say what kind of image this would be. So we figured that out using this side's type and we created our texture. So now what we can do is use side for our side. So Command B to build this, because anytime we do anything new in a different file, we have to build our project. Then we can use what we've done. So game scene. And now our side, rather than being a sprite node, will be of type side. Open bracket, and we will now do our initializer. So this here is our initializer from here. We're going to ask for a color type called type. That will set what type this side is and will play a very important role when it comes to setting the right image. So now rather than setting the image, we can say this will be color type dot blue, for example. This will then tell our code that this side is the blue side, and because of the way we set this up, this will have the blue image. Now because it knows type has to be a color type, we can just say dot blue. Make this side the blue type. And because our side is now of type side, not only do we pass in what type this will be and it will figure out the image for us, side now has a property of type. We won't be using this here, but side now has that property which is storing what side this is, which will be very important when it comes to seeing if the ball has hit the right side or not. So it now has that property that we need. So let's hit run and let's check that out and make sure it's still working fine. So this is our game so far. We now have 7 sides which each have this extra property. That's really important for us in our code, but they're all still blue. And now that we have finished setting up our custom class and using this custom class for our sides, we can now make each of our sides be a different color. So we want each of our sides to be a different color, but at the moment they're all blue. And that is because we're still telling our code to make all of these sides the blue type. Because remember, when we make our sides, we're only really coding one side, so this exact code will run over and over again in the loop. So here, if we say make one side blue, because this exact code is running 7 times, all of our sides will be blue. So rather than just directly typing in a type here, we have to do something a little bit different. To do this, we have to make a list, an array of the type of sides that will make up the color wheel in the order that we want them to be. So we will make a list of 7 types. Then when our code is making our color wheel, we will simply tell our code to set the first side to be whatever the first type on this list is. Make the second side whatever the second type on this list is. Third side the third type on this list, and so on. So for this we need an array. Because we will use this array in different classes throughout this series, we will put this in our models and data. We will then be able to access this list from anywhere in our project. So all we have to do is set up a new array called color wheel order. This will be an array of color types, and we just have to list the order of types of our sides. So effectively the order of colors we want for our color wheel. So color type.red. The first side we'll make, we want it to be red. The second side we want will be orange. Now because color wheel order knows this is a list or an array of color types, we haven't got to say color type.red, we can just say .red. So the order we want this to be, we want the red side, then we want the orange side, then we want the yellow side, the green side, the blue side, purple side, and pink side. So just make sure you have all 7. So we now have this list of the colors we want in our color wheel in order. So now quickly Command B to build so we can use this. Game scene. So now what we have to do, rather than straight in here saying set the side to be blue, we will say set this to be something from our list. So type will be color wheel order, the name of our array, and then something from this list. So quick bit of recap about arrays. This here is an ordered list. and these each have an index. So this here is index 0 or item 0. This here is index 1 or item 1, index 2, index 3, index 4, index 5, and index 6. These each have a number associated to them, which relates to where this is in this list. If we want to get one of these out of this list, all we have to do is say go to color wheel order and go get me index 0. This will go get index 0, so the first item on the list, and set that to the type of our side, which effectively is also going to be our image. So as the first one on our list, in my case is red, if we say go to index 0, all of our sides will be red. Like so, which actually looks insanely cool. Check that out, I like that. If we were to say go to index 1 instead, these would all be orange. Like so. So any number we put here, it will go to that list and it will get that item off of this list. So one more example, if we was to throw 3 on, it would go to index 3, it would get green, and it would set all the sides to green. Which again looks really cool. I like that. So the point I'm trying to make here is this number here now affects what kind of side this is going to be. So what we want to do is we want to take this code here that's running in a loop. So remember, this exact code is going to run over and over and over again 7 times. So basically what we want to do the first time this code runs in this loop is have this at 0. So this first side will be index 0, the first item on our list. It'll be red. The second time this code runs, we want this number here to be 1. So it will be the orange side. The next time this code runs, we want it to be index 2, the next time index 3, and so on, all the way up to index 6. So how can we do that? Well, you might remember from part 1 that in our for loop, we have a number. This number, at the moment, we haven't given a name. We will now give this a name, I. So quick bit of recap. Now, the first time this code runs in our loop, I will equal 0. It will reach the bottom, start again, add 1 to I, and run again. So second time, I equals 1. It will reach the bottom, add 1 to I to 2, go again, and it will keep doing this up to and including 6. All we have to do here, rather than putting a number, is say here, be whatever I is. This means the first time this runs, I will be 0, we now have 0 here. The second time this runs, I will be 1, we now have 1 here. Run again, I will be 2, we now have 2 here, up to and including 6. So now the first side will be index 0 from our list, red. The second side will be index 1, orange. The next side will be yellow, next one green, blue, and so on. And now, using I, each side will be a different type, therefore different colour. Hit run. Just like so. So the first side is our first type from our list, red. Next side is our second one on our list, then our third one on the list, fourth one on the list, and it just keeps working around. So now, this list here entirely controls the colours on the colour wheel. So if we was to change some of these, let's mix this up a little bit. Let's put blue next to red, and let's throw orange down there. Hit run, and just by changing this list, we now change our colour wheel layout. So blue and orange have swapped. So undo orange and blue, put it back to the right order. So just by changing this list here, you can make completely different versions of this game. And if you added more side images, you could make almost an endless number of versions of this game. So let's have a quick look. So this is our default colour wheel, and just by changing this list, here are different versions of this game that I've made, just by changing this list. See how cool that is? Quick fun fact, the game in the bottom left hand corner of the screen, the one with all of the red sides and one green side, was very, very close to being the game that we made in this series. And rather than having a random coloured ball, all of the balls would have been green. And sort of had a change of heart at the very last moment. But the point there is, by making some very small changes to your code, you can make versions of this game that are quite different. And at the very end of this series, so after we have finished making the game, I'll be showing you a whole bunch of different ways that you can change this game to really make it your own. So wait till the end of this series to play around with stuff, but start thinking about how you can change this game and how you can make it your own. stand out with it and release it on the App Store. Okay, so we now have a colour wheel with a different colour for each side, and when we click on the screen, our colour wheel is going to spin. And we have now completely set up our colour wheel structure. So that wraps up this video. We have now completely set up our colour wheel. In the next video, we will set up the balls and make a randomly coloured ball move to a randomly selected side. We will also take care of the start of the game, so you have to tap on the screen to start the game. So as always, thank you very much for watching. Leave any questions or any feedback down in the comments. Hit like, hit subscribe, and I will see you next time. Goodbye.